morning, students. I am Kathiravan, Department of Chemistry. So, my first today we are seeing the ionic bonds. So, bonds is important in chemistry. In every chemical reaction, the bonds are involved. In a chemical reaction, old bonding is break and new bond is formed. So, in reactant, old bond is broken, and in product, new bonds are formed. So, types of bond first. So, ionic bond. So, ionic bond's other name is electrovalent bond. So, it's bond formed between the ions. So, positive ions and negative ions. How the positive and negative ions formed? When an atom loses an electron and it forms a positive ions, namely cations. And an atom accepts an electron, it forms a negative ions, namely anions. So, the bond between anion and cations is called ionic bond. So, electrostatic interaction. So, oppositively charged attractions takes place. So, the ions between the ions, the bond is made. So, it is ionic bond. For example, so we are seeing the sodium chloride an example. So, sodium, so atomic number is 11. So, in electronic configuration is 1s2, 2s2, 2p6, 3s1. So, in outermost orbital there are only one electron is available. In this, the sodium metal is lose one electron and it gives the sodium plus ions. So, it lose one electron. So, it have sodium plus Na plus single positive charge is formed. Similarly, in chlorine atom, the atomic number is 17. So, the electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p5. In outermost orbital, there are 7 electrons in third orbital, and it gain 1 electron from the sodium metal. So, chlorine ion gives to chlorine anion. So, Cl minus ions is formed. So, the positive ions and the negative ions, the bond between the electrostatic interaction between sodium plus Na plus and Cl minus, it forms NaCl. So, its representation is important. Next. So we also represent this type of representation also we represent. So, another example is magnesium chloride. So, in the similar way, so Mg, so 3s2, so outermost orbital magnesium have 2 electron. So, magnesium loses 2 electron and it have Mg2 plus ions. So, in Mg2 plus ions, they give one electron to one chlorine atom and another electron to another chlorine atom. So, one magnesium ion form two bonds between two chlorine atoms. So, MgCl2 is formed. This is another example for the ionic bond. In this theory state, an atomic orbital combined to form a molecular orbital. So, this is the main theme of the molecular orbital theory. So, in this picture, so in y-axis we have taken the energy. So, atomic orbital and atomic orbital combine to form molecular orbital. So, one is below the atomic orbital's energy level. This means the bonding molecular orbital, and form another one is the atomic orbital's energy more than the atomic orbital's energy level. This means the anti-bonding molecular orbital. So, atomic orbital combines to form bonding and anti-bonding molecular orbitals. So, in this example, so it is for common. So, 1s orbital and 1s orbital of two atoms combine form sigma 1s and sigma star 1s. So, how sigma bond is formed? So, headwise overlap of two orbitals, may it s orbital or p orbital, or the s with p orbital may form sigma orbitals. So, bonding molecular orbital sigma, anti-bonding molecular orbital sigma star. So, in pi bond, the sidewise overlap of orbitals, it forms pi bond. So in this manner, in the p electron, so first head to head overlap of sigma bond is formed, and the perpendicular p orbitals are sideways overlap to form pi bond. In this way, bonding molecular orbitals are pi, and anti-bonding molecular orbitals are pi star. So this is the important for the molecular orbital theory.